Okay, in this video we will explain the idea that is called the chebenshev inequality. It sounds complicated, but really it's very easy. First I'll say what it says, and then we'll make a nice picture, and hopefully it'll be very clear. What is it, first of all? It is telling us a rule about how much of the data is outside a certain point. I'll explain it to you in a moment. Okay, we all know, first thing, before we start, there is such a thing that's called E of X. What that means is that there is X can be many numbers, let's say 1, 4, 7, 8. These numbers can represent the height of people, the weight of people, any kind of data. And we give certain percentages for each number. So let's say we have groups of 4 different kind of people, and there's 10% of people. I'm just making up. It's not a reality, but just to understand what the idea of expected value is, it means like as follows. We have 4 types of people. I'll make a chart to understand. Here you go. There is 20% of the people weigh 50 pounds, 30% weigh 60 pounds. I'm sorry, I made the wrong numbers here. 0.3, and I'll make here 0.1, and here will be 0.4. Let's do it again. 20% weigh 50 pounds, 30% 60 pounds, 10% weigh 70 pounds, and 40% weigh 80 pounds. I know it doesn't make any sense, but just think about it theoretically, that this is what the distribution is. So we have here, it can be 50, 60, 70, or 80, and this is the percentages of 50 pounds, and so on. So everybody knows that there's a way how to find out the average. How is that? Very simple. You multiply each number, the top, times this. You can start from here. 0.2 times 50. 0.3 times 60. 0.1 times 70. And lastly, 0.4 times 80. So if you do the math, I'll take a calculator and I'll do the math to find out the average of the weights. Is 0.2 times 50 plus 0.3 times 60 plus 0.1 times 70 plus 0.4 times 80. 67. EX is equal to 67. That's the average, 67 pounds. You can see it makes sense because it's closer to 70, because there's more. If you realize there is a higher towards the 80. The 80 gets 40%, so that's why it pulls more towards the higher numbers. It's not 65 as one would think in the middle number, it's rather 67. Okay, that's quite simple math that everybody can do with a calculator. It's not a big deal. Now we wish to know something that is as follows. This is a very simplified case. Might be, however, much more numbers involved here. Might be 50, 51, 52, 53, all the numbers from 50 to 80, and each one might have a different percent. Understandably, they must add up to 100%, so one might be 0.01, 0.2, 0.13, all kinds of different percentages. Again, the EX you can figure out easily. But then, let's say we give you a certain EX, and we wish to know what percent is off a certain number. I'll explain to you in a diagram what I'm trying to say. Look at the bottom picture. I wrote 65, and then you see these curled things here. So the question is, both sides I'll make 8. As you see, they're 8 units away from both sides of 65. So 65 plus 8 is 73. 65 minus 8 is 57. So we're asking now, what is the probability, the highest probability, what's the most that the people or the objects that we're considering should be either above 73 or below 57. That means 8 units away from 65. So we're choosing a certain number. That number can be any number along this whole list of numbers we're considering, and we wish to know this number will, both sides will count 8. You can count 7 or 6. I just chose to count 8. So what will fall on both sides of this empty area? How much is the most possible that we might have? Obviously we don't know exactly how much, but we're trying to figure out the most possible to have on these sides. Okay. Okay, so this is the way how we do it. The way it works like this. Since we know that the expected value is 67, we're asking now how much of the data can be above 73. Is it possible for a very big chunk to be above 73? Or if that will happen, then we cannot have an expected value of 67 anymore. You understand that? Imagine 70% of the data or 80% of the data is above 73. is above, I'm going to write down the numbers here, is above 73. Let's first talk a very exaggerating figure. Imagine 90% of the data is above 73. So we do 0.9 times 73, 65.7. Okay. Let's make it even worse. Imagine that 95% is above 73. So it's 0.95 times 73. 69.35. What does that mean? It means, imagine, it's a very exaggerated situation, but imagine that you have this area here, the area that's above 73 is 95% of the data. If that would be true, then the average would be 69, much a higher average. And we are assuming the average is only 67. So that forces us to say that we cannot have such a great amount of data above 73. So we see certain kind of assumptions. It's a very weak assumption. It doesn't teach us too much at all. But at least we can make a certain statement that, again, what is the point of this? The point is, if we know the E of X, it gives us at least some minor kind of information about the distribution. What information does it give us? Very little. It tells us at least, at the minimum, that you cannot be crazy and say that 95% of the data is above 73. So again, the question starts off, let me just repeat the question. The question starts off, somebody comes over to you and asks you a question. We chose the number 65, but that's meaningless here. The point is, we want to know 65 plus 8 is 73. The question boils down, how much of the data is possible to be above 73 and still not ruin the EX of 67? So if a tremendous amount will be above 73, that will tilt the EX. So if you put there 95%, it's impossible anymore to have EX of 67. So we cannot push all our goods, all our stuff above 73. At least we cannot push more than 95%. Let's try to make, how about if you make 93%? I'll do it with a calculator. I'll show on the screen. 93.93 times 73. So imagine that you have 93% of the data above 73. Obviously, if it's higher than 73, it can be 74, 75. It will be even bigger than this. It's 67.89, also no good. So I guess somewhere 92% is still possible, at least very far-fetched, but it's possible. I'll do once more 92 to see what you get here. Oh, you still get 67, 91. It will be the right answer. 91. Here you go. 90.91 times 73. 66.43. That is, you can have, you can imagine at least to have 91% above 73. It can be 73, 74, 75. It cannot be too much higher than 73, because then again it will tilt it too high. But But imagine that all of the 91% of the data is exactly by the point of 73. Then we get an average of 66.43. That number is still not a high number. It's still less than 67. Again, we make an assumption that the EX is 67. That's how we started off with this proposition. We're trying to figure out, according to this proposition, how much is the most that you can go above, how much is the most you can put on that scale above 73. So to sum it up, if you realize now a certain pattern, the way to do it is you simply take the number 73 to know exactly the amount you can put on the scale. You write down like this. We wish to know what number times 73 is equal to 67. That's exactly our question. What percentage? Because that's the most we can put at the point of 73. So it's 73 x times x is equal to 67. Divide both sides by 73. So x is equal to 67 over 73. I'll show you on the paper. $73 x is equal to 67. X is equal to 67 over 73. This is the algebra that's involved here. 73 times x, x is a certain fraction, it's 0.91 something, is equal to 67. That means how much can you put on the number 73? How much weight can it handle? It should not go above 67. That's the x. That's 67 over 73. If you put more than that, it will tilt it. It will be higher than 67. So that tells us, in other words, the most. Again, it definitely can be much less. It can be much less. It could be that there is much less than 91% on 73 point. At least we're telling you now the most that can be on 73 or above. Actually, if you above, then it must be less, because then it's again tilting it too far off 67. But the most that can be on 73, and needless to say above 73, is 67.7. Don't even dream to put more of the weight of this distribution of that's 67 over 73. That's like 91%. Don't even dream to put more than that percent above 73. If you wish, you put them below 73 and so on. Maybe the lower numbers. You can do different. You can have all kinds of different ways how to distribute something that the average to be 67. You can do different, infinite different ways how to get average 67. But one thing, don't dream. Do not take more than 91% and place it above 73. This is this video. Next video we'll talk about something similar to this. Thank you for listening.